Good day, Ms. Yesa. Here is a presentation about our Culminating project. Our field of endeavor is business math.
It shows the formula of the maturity value, which is MV equals the principal times 1 plus rate times time. And we set the maturity value to be dependent variable and the principal to be the independent variable. And as we substitute this in this formula, we can get 1.05x. The domain of this is x sub x is greater than or equal to 0. And the range will be y sub y is greater than or equal to 0. The asymptote of this one is none. So there's no asymptote here in the graph. The zeros, we have only one zeros, and that is 0 and 0, which is the origin. And we can say that this 1.05x is a linear function because it follows the format of the linear function.
For the principal, which is P is equals to I over RT. The dependent variable is P and the X is the independent is time. We have here 5% as the rate and 1,000 as the interest. Here is the formula. Here is the simplest form of the formula, and this function has the domain of x such that x is greater than 0 and a range of y such that y is greater than 0. It has an HA of y equals 0 and a VA of x equals 0. It has no zeros, and we can consider this function as a rational function because it follows the basic form of the rational function, which is y is equal to 1 over x.
So, coming over to the logarithmic function, we use the formula for the number of years, which is ln f over p over ln 1 plus I. So we use number of years as the dependent variable and the interest rate as the independent variable. And we assign the values of p as 1000 and f as 1500. So when we plot these values in the function, we'll get the function y equals ln 15 over 1000 all over ln 1 plus x. The domain of this function is x greater than 0 and its range is y greater than 0. The asymptotes is x equals 0 and y equals 0, and there are no zeros in the graph. We can say this is a logarithmic function because, as you can see here, there is a variable in the argument.
So lastly, we have the formula for our terminal rate, which is NM root over F over P minus 1 all over M. So our Y is the nominal interest and the X is our future value. So here, the principal value is 1000, the number of years is 2, and the M is 2. So when we evaluate these values to the formula, it will be y is equal to 4th root of x over 1000 minus 1 over 2. So the function has the domain of x greater than or equal to 1000 and a range of y greater or equal to 0. There are no asymptote though. There are 1 0, which is 1000 and 0. It is a radical function since there is a variable inside the radical sign.
Okay, here is the inverse of all the functions that we have talked about a while ago. As you can see, this is the linear function, and its inverse function is y equals x over 1.5. next one is the rational function. And you'll notice that here the inverse function, which is the same as its original function. And next one would be the logarithmic functions. After computing like this long, we approach here, which is y equals to x root of 3 over 2 minus 1, which is the same as y equals to 3 over 2 raised to negative x minus 1. Lastly is the radical function. And with this combination, we get this result, y equals 1000 times 2x plus 1 raised to 4 at last.
So this graph represents this function, which is the 1.05x. And this shaded region represents this inequality, which is greater than 1.05x. So any point here in this red shaded region could make this function true. And this red dot represents our zeros, and it's also known as, which is also called as the origin.
This is the rational function, and this is the graph of the rational function rather, and this is the function. The line represents this function, and this red part is the asymptote. The shaded red part is the inequalities of the function, and any point at this region can make this inequality true.
Good afternoon, Miss Cesa. So this is the graph of our logarithmic function. So first, this shaded area represents the asymptotes, the horizontal asymptote and the vertical asymptote. This shaded area represents the solution set of the inequality. So any point within this shaded area can make the inequality true. There are no zeros for this graph.
This is the graph for the radical function. The red dot represents the zero of the function, and the red shaded part represents the solution set of the inequality. So any point within this region can make the inequality true.
Okay, here is the other functions that I provided, which is the g of x equals to 1 plus x over 2 all raised to 2 minus 1. And this is a function for the effective rate. And I use here, the operation I use is the composition. So g of f of x is equal to 1 plus square root of x over 1000 minus 1 over 2 over 2. And all of this squared and minus 1. Here I changed a little bit, make it a bit different from the original function, because the effective rate here is talking about the number of times that's compounded every year. So instead of using 2 years as the end, I removed it and make it back to 1. So we can cancel everything here, 2, the 1, and the radical sign here. So at last we got this, which is g of f of x is equal to x over 1000 minus 1. And this is our function for the nominal rate.